I'm Jeff Nielson. I'm now at Kettering Health Network in what's called Kettering Health now, in Dayton, Ohio, and I'm going to talk a little about data assets. And so when you embark on a project like this, your data is the thing you need, right? And you think it's all in the EHR, and you've been complaining or asking your IT guy about how, well, I put it in, why can't I do things with it? So I wanted to just talk about how the data exists in your health record a little bit, and how that's going to influence maybe the projects you do, so we're just going to talk about it. So, I label this the reporting data lifecycle. Data lifecycle generally is in terms of like how the data exists in your system over time, and how you manage it, and how you throw it away in the end. But with regard to us today, it's about how is it structured for you to use for an AI project, and where you're going to want to get your data from. So in your electronic health record, you're typically using this operational data. It's data that is organized by the patient. And then there's also this reporting data, which is more organized by either visit or by the patient, and it's organized in a different way. And so we're going to talk about how it's organized, and then at the same time, your data goes through a process where the same data through the steps is organized to be an analytics setup. So when you log into Epic or Cerner or Meditech or whoever, the data is not stored in the way you're taught, like in a CSV file, or usually even in a relational database. It's set up more like an XML file, or like one of these. It's more in a document-ish, where you have a patient who has a bunch of information there with it. More like you'll have lists of things. You'll have it organized in a way that allows for you to quickly get information that's grouped to the patient, rather than grouped in a list of all the visits that have ever happened of all the patients. So it's not set up so much in a relational database. And so these in the past, they've been called either document databases or key value stores, and nowadays they call them NoSQL databases. So this is what we typically call your primary data. And when you're doing an AI project, the data that you are writing your algorithm with doesn't look like this. This is the data that you're using to do the decision support in real time. And so it's important that you recognize that this is the data you're using in real time, and it has some of the information you might need to do your decision support. And in other cases, it won't have everything you need. All right, so when you first take your data science class or whatever, they teach you about databases, and this is and you get the idea that everything is in a relational database, and this is what it gets converted into when you go to do reports and things like that. So on a simplest level, you're going to have you might have data like this in your NoSQL type data with a patient with many visits, but when things are converted over to a relational database model, they make a bunch of assumptions, most of which are pretty good, but some of which will end up being tricky for you. And they end up putting everybody's visits into the same table, and that typically isn't the way that you need to be thinking about things. And so in this conversion, there are times when you want to have a list of everybody's EKGs, and first say you're doing a search on, I need you to can I pull up every EKG that had ST elevation? But typically, when you're doing operational data, that's not a clinical question that you're going to have. So, and in this conversion are these various assumptions are going to have a very serious impact on the machine learning model that you use, because it really is. You'd think it'd be simple, but it's not. It's a big jump. Every time you ask a question of a database, just like if you every time you examine a patient, there's a little bit of difference in the answer you get. So like every time I ask a patient, do you have a headache? They might say yeah, or was it sudden? Sometimes they say it's sudden, and then sometimes they say it wasn't so sudden. And so in that case, I'm using time as a difference, or perhaps the emphasis I use, or whether or not I'm a nurse or a doctor provides different questions. But with data, you get the same thing. No matter how you ask the database, any change you make in your data structure is going to change the outcome you get, which is really one of the most fragile things about the AI we do. All right, so let's see. I want to talk a little bit more about this analytics data. So we talked about the operational data being a little bit different than the reporting data. With analytics data, it's set up in something called a star schema. So it's the data still in this relational database, but the star schema sets it up so that you have a fact table, it's called, and then you have descriptors. So you have these other tables that kind of help you with information. And so it isn't so. The important part of this is that it speeds queries for slicing, dicing, as we say, which is similar to the filtering and grouping, and being able to do queries on your own on the fly. Whereas you can't really, it's harder to do queries on the fly with your typical reporting data. But I just want you to be aware of these kind of ideas, that it might be that you have an analytics database. In Epic, these are all separate. In Cerner, they're all separate. So just make sure you understand what database you're using when you're getting your results from your vendor, but it's usually actually your local analyst who's helping you with that. Okay, so the next thing I want to talk about a little bit is, well, where are you going to get your data? So these acronyms you may have heard, like PCORNet, I2B2, OMOP, OHDSI. So these are standardized data sets which may be helpful for you to begin your your machine learning process. So there are 80 institutions that are using PCORNet, about 200 using I2B2, and about 90 using OMOP, and there's a lot of overlap among these. These are data sets where, it's a value, or it's a data structure, and you convert all of your clinical data into this so that you can write a standardized query and you can share it among institutions. So if you're lucky enough to have your institution, and these of course are the larger academic institutions who have all their data in I2B2, what you do is you apply to get, you have to talk to the person administering it, and it's going to require a little grant or institutional or whatnot to be able to write a query for it, and then you can write the query to get that data locally, and as soon as you know that it works, you can then put it out on on their little forum for sharing data, and you can get data from other institutions, and so that you can have a much greater N for your study. So these have been around for between 5 and 15 years. They're remarkably helpful, and there's a lot of federal funding behind them. So if you've heard any of these acronyms around your institution, then find that as a good data source. All right, let's see. So if you want to know a little bit more about OMOP, or which is so that there was an OMOP organization, but it kind of transitioned into OHDSI, but the standard's still called OMOP. Anyway, these kind of things happen. But the important thing is that if you are interested in seeing, how some of this is organized, you can use some of these links, Athena or Atlas, to query them and see, okay, is there an EKG procedure, or is there a troponin? And for the most part, really, they do have the data in there. However, you're going to find that some of these will qualify the data a little bit better or a little bit worse than others. And some of them are set up differently. For instance, I2B2 is more organized to do analytics, whereas PCoreNet typically is really flexible at getting just about any kind of data in it. Okay, we've talked about some of these principles, but I wanted to just kind of go over it in your minds a little bit. Your process is going to be that you find some source data, either local or regional or through I2B2, and one of these places, and it's going to be archived data. It's going to be data that is not all of the data from your hospital. It's going to be months old, or it's going to be years old, and you're going to process it into something that hopefully still represents reality, and it's usually external to the patient. So that that's an important thing to realize is are you going to be using patient data from, am I going, like for the machine learning models, is it just that I want to look at all the patient's blood pressures and then decide, is this blood pressure abnormal, or am I going to look at everybody's blood pressures to decide whether or not this is abnormal? This process that I'm talking about is more of a using everybody's. But then you go through the effort of creating your AI algorithm, which so many good examples were just given. And then the next step, though, is getting it to be inside the electronic health record. And do you want, some of the decisions you have to make is are you going to create a greater data collection burden? Are you going to ask for more? Usually what we see is, like for instance, most of us are out there right now dealing with the fact that when we order a CT scan, we have to put the reason for it. But you've already dictated the reason for it in your text. And so, but most EHRs still have a data collection burden for you, where you have to put in the reason for your exam, even though it's pretty well, in place there in your in the HPI as you've already created. So. So anyway, one of the processes that you'll go through is trying to figure out which data you're going to get from which real time and which is going to be pre-prepared. And then I'll just skip this, but because I think someone else is covering it. But it's really important that we do more than just localized QI QA. We have to be doing local, we have to be doing external validation of these. So I wanted to talk just a little bit about what our local institution's doing as far as what they call AI. You're going to hear so many things. Someone mentioned earlier that that AI is helping Dragon, right? I mean, that surprised me. I wasn't going to guess that AI was going to be the thing that made Dragon work when, 15 years ago before Dragon started working. But, I got to hand it to them. They applied it, and some sort of machine learning algorithm really helped them. And so, as much as I sometimes am negative toward machine learning and AI as an idea, I'm surprised at all the different places where it just works. So the one that we're using is, we have a vendor which is not called AI. I kind of scratched their name out here, but their promises are that that they're going to use their little engine to pull out data from any one of these vendors and create this deep data set, which comes mostly from machine learning, I should say mostly from data extraction from text reports, which is machine learning, which they've used. So it's an algorithm, and then they promise nightly that they're going to do data extractions and then load up this AI thing so that, I don't know why they put real time here, because realistically it's just real time here, be able to get data from their tool. So as you're kind of thinking through what your, how you want to use AI in your projects, you really have to decide, how do I want to do it? Do I want it to be based on electronic health record data that's live in my EHR right at that time? If that's your answer, then, well, it's going to be, it's a different project than if the data that you're using comes from the stuff that's been extracted, say 2 or 3 months ago. So I bring it up because it's going to really influence your process and how much money it's going to take, and whether or not, what decisions you make in your research. So I sort of already talked about that. Okay, so as far as being able to get the data while the patient's in the emergency department or during their clinic visit or whatever, the government has required now, with this 21st Century Cures Act that had lots and lots of provisions, but one of them was that the vendors have to make data available to you in the FHIR format. So the FHIR format is different than the vendor's API. The vendors are, they wanted to open up decision support and things like that. So, they'll have a way for you to pull out data elements, and it's usually consistent across different vendors. It'll work. If you want to pull blood pressures, it's going to pull blood pressures, and you're going to be able to say things like pull the last blood pressure, pull, whatever, the last 24 hours of blood pressures. And so FHIR data is more standardized across vendor systems. However, it also is not quite yet consistently implemented. And so you're going to want to look at both of these options as you're looking at real-time projects. So FHIR data is going to be about 50 to 80% consistent. And there's versioning with FHIR, which is a little bit problematic. And so the government's requiring everyone to stay with 21st Century Cures. The rule is that they have to stay within one version of current, which right now they're all just trying to catch up and do it right. And then some of the data, FHIR allows for you to, there's a whole other lecture on FHIR, but the point with FHIR is that you're not always going to get what you expect, and there's going to be gotchas, and so you're going to have to work with them. You have to make sure that your site is ready to update their code, and so that you can get exactly what you need. For instance, like if you ask for blood pressure readings in FHIR, you're going to get all the readings rather than just being able to cut to just the last 5 readings or this visit's readings. Some of the things that you need to be aware of, and this is about rounding it out. I think I've got just like 2 more slides left. Are that I've talked a lot about how there's a lot of transformation that occurs when data goes through these processes, and that will definitely influence your results, and you need to be aware of that. Data provenance is an important science. There's going to be sometimes in the data that you're using to do your machine learning, you don't know exactly where it came from, and so you need to make sure that you've understood its process through each one of these steps. There's issues of chronological definition stability. Hypertension changes. What does hypertension mean? That term, it's become more stable over time. But what if there are times when one day to the next they've decided that hypertension means one thing or it means another, or COPD means one thing or another, or coronavirus used to mean something totally different to our group 5-10 years ago. So even though realistically, so I guess from a practical standpoint, coronavirus means something different, but from a technical standpoint, it didn't change that much other than that we have a new strain. So you just have to be really careful about how those kinds of things affect your data. You know, there's so many examples that anyone who's worked in this data has come across, and so I just wanted to introduce these issues to you again. It's just that one project was that we were discussing was we were trying to look at gunshot wounds, and we were looking at I2B2 data, and everything, like whether or not it was a gunshot wound, just it wasn't present. You know, so even if you code it one way, it can get grouped into just all penetrating trauma in the data set, and so you can sometimes you lose things in grouping, and then this concept that I've already discussed, that you're going to get a different result based on how and where you ask. And then I'd caution you to always think through what value you're actually looking for and who your audience is. Most of us in this room are interested in improving our clinical, either our clinical ability or of an individual to make a decision, or of a group to make better decisions. And then there's also, of course, the idea of trying to improve finances. I wanted to make sure you guys were aware of some of the data sets you can use that don't involve going to your institution and going through the 6 to 12 month process of actually getting data to work with. Earlier, someone mentioned the MIMIC database, which is it's pretty easy to get a hold of. And it's got 40,000 ICU patients in it, and it's free. So we use that for an EKG analysis project, and there's obviously lots and lots of stuff in there. And then the CDC has released chronic disease data, and then there's also this kind of interesting thing called the HCUP project, which some of you may know more about than I do. But I really like the idea that there are, there's a big sample of data out there of ED visits. Stepping back from it just a little bit, let me just say that, just because I didn't formally introduce myself, I've been doing this for a long time and found that I've asked a lot of questions, and I've done a lot of little projects, all of which I never felt like were able to kind of pass the threshold of being able to help me make a better clinical decision. People have done predicting admission, or we did predicting admission, and we couldn't do it. I mean, we could do it. It was better than just nobody looking at them. But was it better than a nurse, or was it better than a doctor? And did it really matter? And did it make a difference? And so you really need to look at what your goals are as you're doing this. And so if you don't, then you're going to spend a lot of time hobbying around rather than creating data that you feel like is really worth publishing. So anyway, those are my thoughts. And I'm going to kind of turn it over to Ian, who has more information on his implementation. Yeah, go ahead. I2B2 and Picornat, yep.
Yeah, so I want to know what's their relationship with HIEs? Are they also similar in that they standardize the data formats as well, or is it more that HIEs are the source of the data going into the
Okay, so let me answer that question. Okay, so I2B2, Picornat, and those, that's more on an institutional level to normalize the data to a format that is useful for research. So, or different questions, that are like that, analytics. So there's that. And then HIEs typically receive data as CDA documents. So their data is, it comes differently. And so as far as I know, there aren't any HIEs that are receiving the data in those research formats. The research formats are mostly designed to be anonymous, those ones that I was talking about. So that, now they're not totally anonymous because their timestamps are real, right? I mean, you can de-anonymize them, but that's one of the requests, or one of the requirements of using them is to promise not to de-identify them. I'm not sure if that actually answers your question, but I hope it kind of separates it into like why, they have very different use cases. And then, I should say another thing about HIEs. Just, HIEs of course, are trying to maintain identification of patients. Although there are HIEs which, they're obviously everybody needs to stay in business, right? They got to keep things afloat, and so their goal as an HIE is to gather as much data as possible so that they can then anonymize it and sell it to other companies. So I'm in Ohio, and in Northeast Ohio, the HIE was very focused on trying to sell their data. And then the other one that is through all of Ohio has no desire to be selling their data. They're just feeding it back. But as you probably are aware, most of the HIEs that got 10 years ago, 15 years ago, that started, most just went belly up because they couldn't figure out a financial model. They started with grants and then kind of fell apart. A little bit of a tangent, but it's important to know that. All right. Any other questions before I turn over to Ian? Okay, great. Thanks.